Hello, my name is Saljug Mammadli, and in this video I'll briefly walk through the experiment that I've performed for our physics lab, which is investigating how capacitance changes depending on two separate factors: the dielectric material used between the capacitor plates and the distance between them. First, I would like to walk through the theory. The equation for a parallel plate capacitor without any dielectric is, as you can see, this, where C is a capacitance, this is the permittivity of free space, and A is the area of the plates, and D is the distance between them. And when we place a dielectric between the plates, the equation becomes like this, where K is the dielectric constant of the material. This means that a better dielectric increases capacitance, and increasing the plate separation decreases it. In this experiment, I've tested multiple materials like foam and wood and etc., and varied the distance between the plates to see if the results match the theory. Okay, so in this experiment part of the video, I'll show you how I've connected the multimeter that leads to both plates of the parallel plate capacitor. The multimeter is set to capacitance mode, as you can see, and I am putting different dielectrics and measuring the capacitance through the multimeter. I'm inserting different materials such as different types of foams, wooden material, and etc., as you can see through this video. And I just repeat this process, adjust the distance between the plates when you put it so that it fits tight, and observe how the reading drops and increases as I change the material, as you can see from here. And in the second part of the experiment, we have a similar setup, but here we don't have a dielectric. We still measure it with the same setup, but this time we just decrease the distance between the parallel plate capacitors and see how it grows as we decrease it. As you can see, a bit decreased, and it growed from 18 to 27, for example. And when you put the distance high, it increases, as you can see from this setup. Now, let's look at the results that I've got. As expected, from this graph that you can see, the capacitance increased when I used materials with higher dielectric constants. As you can see, whenever we have used a wood material with a high dielectric constant of 4, the measured capacitance that we got was 33 in comparison to air or foam, which would be 13 and 15, for example. Then, when we look at the graph of it, we can see that there's a clear linear relationship between these, the capacitance and the dielectric constant, proving our point that from this formula, as we can see, capacitance and dielectric constant are directly related. And now let's look at the second graph, where we have varied the distance of the plates using only the area. And as we can see, the more we increase the distance of the plates, the measured capacitance decreases by quite a lot. This confirms the inverse relationship that between the distance and the measured capacitance, which you can also confirm from the graph that we have shown here, which shows the linear relationship between 1 over the distance and the measured capacitance. I've also compared the values to the theoretical values, as you can see here. For example, this is the measured capacitance that we found, and this is the calculated one from the theory. And all of them do follow overall trends, but they don't match exactly due to a lot of errors that could happen during the experiment, such as non-uniform materials, the fact that the setup was a bit old, and etc. Overall, the experiment helped me understand how capacitors behave, and it showed that the theoretical equations really do work in practice,